Okay, if happen that you have played Game Boy, then this thing over here or this example over here will be very closely related to you. Okay, if you still remember, the Game Boy itself uses 2 AA battery, which is 3 volt. Alright, and you still remember when you play your games, your whatever games that you're playing, then a long time, alright, your screen over here is gonna be getting dimmer and dimmer. Alright, you're starting to cannot see your screen anymore. Right, because the power has been is going to be depleted. Alright, and you still remember there will be a red light. Alright, if I zoom in, there will be this light over here telling you the power of your battery. Okay, so this red light, as the time goes by, it will be very dim, you cannot see anything. Okay, so this means that your battery is going to be depleted. Okay, so if you think about it, at first you put in 3 volt. Alright, the screen itself is very bright, it's at the full power. Okay, and as time goes by, as the power discharge, alright, as this percentage discharge, alright, you're gonna decrease. Right, you're gonna decrease as this loop goes by, right? This loop over here. Okay, this for the alkaline lah. Alright, and at the last point, at the last speed of power, you can only supply 0.9, right? Because if you 100% finish the battery, it's approximately about 0.9 volt. Correct? So we can also say that in order to power up this Game Boy, you minimally require 1.8 volt. If it's 1.7 volt, then you will not power up the battery. I mean, you will not power up the Game Boy. So minimally, you require 1.8 volt to power the battery. This is also the additional reason why we can plug in this particular light over here. Alright, this additional light that is for you to see the screen if you were to play in the dark, alright, is taking in, I don't know, I just anyhow pump. For example, 0.5, maybe I think 0.2 volt lah. Okay, don't be too high. Or it's approximately 0.2 volt. Alright, so in total, this light over here and the system of the Game Boy in total is taking 2 volts. Alright, so if you think about it, if you have a light over here that is an additional component, alright, then you're gonna take in more power. Alright, so your battery is gonna drain more faster. Correct, and this is the issues that is with regards sentence over here. A higher voltage may be needed for parts of a system such as LCD screen or your headphone amplifier. Much more power is needed for motors or other whatever thing. So much more power is needed for other peripheral things. For example, this peripheral things is your lighting over here. Or this lighting is external components. You can also have a earpiece over here. This earpiece is going to take in another power supply. Alright, so in total, this light over here take in 0.2 volt, your Game Boy take in 1.8 volt minimally, your earpiece maybe take in 0.1 volt. In total, you use 2.1 volt altogether. Alright, so your 3 volt battery is going to drain quite fast. So once you reach about maybe 2.5 volt, for example, alright, once you reach 2.5 volt, if you were to use this graph, 2.5 volt is for 2 batteries lah. Okay, so 2 batteries, 3 volt. Now if it's 2 battery, 2.5 volt, so each of the battery is about 1.25 volt, for example. Okay, so if you think about it, it's about 1.25 is about where? It's about here. Alright, 1.25. So you're about 50% discharge for your alkaline manganese, the red color one. Okay, so you're about 50% discharge. Alright, so if you reach about 50%, alright, you're unable to actually power your lighting anymore. The lighting over here will be very dim. You cannot even see any light anymore. Alright, but your Game Boy can still run, because your Game Boy is still the priority. So if you plug out your lighting and you have this thing over here, then you can still continue to use, because now it is 2.5 volt. You still have about your minimally for your Game Boy is 1.8 volt, right? So you can at least have another additional 0.7 volt to play before your Game Boy goes finish or die or whatever, or battery dies. So you need to be changed or everything. So therefore, this is a brief example of other components. A higher voltage may be needed for other components. Alright, that is coming from the very early videos from the introduction part, and also to introduce or to strengthen your concept of how to use this discharge graph over here, because of the slope, as you can see. Alright, and things like that, and talking about how essentially everything is designed. because every time when we think about 3 volt, we thought that the whole system uses 3 volt straight away. No, it's because minimally it uses slightly lower voltage, and then you require a higher voltage to take care of those power issues that may actually so-called cause problem and things like that. Alright, so this is in terms of how to design your components. I think that is also pretty useful. Alright, so I think I'll leave you to this.